So guys, today we are going to algorithm that's called as association rule mining or a priori algorithm. Now the basic intuition behind this algorithm is this is based on if I know something, so I'll be buying another thing. So it is something like if I know this thing, if I'll be also will be buying the another thing. So people who bought this also bought this. So it was one from the one case study which was observed from the USA. Like there is a strong, or you can say there is a complex association with which the US storekeeper has seen in the some of the grocery stores. So what they have seen, the people, those who are buying the pad of a toddler, is also buying the beer. So this is actually referring to this way, those people are actually office goers. After completion of their offices, they have a toddler, a newly born baby, and since in order to burn out the office stress, so they are taking the beer. So this will give, you can say, the grocery store keepers an idea about like if you bought this, so you should also buy this. So it also gives you an idea to the grocery store keeper, if they are buying one item, so they, what should I place to next to what my item, so accordingly the people will be buying. So let's say if a particular person is buying a bread, so he is more likely to buy a butter. So this will, accordingly, he can arrange his shelves. So this is an example of a market basket optimization problem. Now, let's say, let us consider one example. It is based on this part. Let's say if there are some user ID, and based on the unique user ID, we can see like a person who is watching movie one is also watching movie two. Similarly, there is an overlapping. So person who is watching movie one is also watching movie two, and similarly there is another association. So it is something like if I watch this, so what is my likelihood to watch another part? So this is a kind of a movie recommendation. So what your Netflix tells you as a recommendation videos, it's one of the example is the a priori algorithm or association rule mining. So with this, you can say common patterns. We can find three things. Like if I watch movie one, I am very likely to watch movie two, and if I watch movie two, I'm very likely to watch movie four, and if I watch movie one, then I'm very likely to watch movie three. So these are some of the potential rules that we can make. Now, similarly, these things can also be uptaken by the market basket optimization. So, which is something like, let's say there are some transaction ID. So we generally go to storekeepers or any grocery store, and we generally give them we buy the product, and they on return they give the transaction, or you can say the transaction check. So they have all the details of whatever the item purchased on their databases. So based on the database data, they can find some important insight out of those data. So let's say if a particular person is buying a burger, it's very likely to buy French fries. So we can see another common association. So if a particular person is buying a burger, so he is very likely to buy the French fries. So over here, we again can see, right? So this is how the you can say the common association is there. So if a particular person is buying burger, so he's very likely to buy the French fries. So similarly, vegetables and the fruits. So this will give an idea about grocery store people. So the burger should be kept next to French fries. So or also you can give an idea burger is a one product. If a particular person is buying a burger, so he is very likely to buy the French fries. So this is one potential rule that we can find. So guys, over here there are three parameters that we will be talking about. So the three parameters are, we have support, another parameter is called as confidence, and another parameter is called as lift. So let's talk about all the three parameters. So now this association mining rule is highly used in a movie recommendation system. So let's say In terms of movie recommendation, it is something like number of users watch list divided by the total number of users. And in terms of market basket optimization, is it is something like number of transaction happening of item I divided by the total number of transaction. Now let us consider we have 100 people, since it is having 20 columns and 5 rows, and out of those 100 people, let's say 10 people like specific kind of movie. Let's say for an instance, insert in Interstellar, Interstellar, sorry. Let's say they like Interstellar. So the support will be, as per the formula, would be something like number of users watching list containing M divided by the total number of users which are present. So it is something like 10 divided by 100. So that comes out to be 10%. Now, in terms of, so this is one metric. So it can be like for the item purchase, it can be like, let's say if I, out of the total transaction, if I buy burger, right? So in that way, the support will be calculated. Now, the next part is called as confidence. So in order to find out the confidence, we actually find like, let's say if I watch Interstellar, then what is my likelihood to watch the Batman? So this is related with this part. Like, let's say these many people are very likely to watch the Batman. Let's say 40 people are there if you count. Now these 40 people, out of these 40 people, we can say that these are the people, they are watching both the movies, the Interstellar as well as the Batman, right? So both the movies they are watching. So let me rub this. Yeah. So these people are watching both the movies, the Interstellar as well as the Batman. So the confidence for calculating this would be 7 by 40, right? So if you count like out of 40 people, one, 2, 3, 4, 5, 6, and one underneath it, 7 people watch both the movies. So the confidence for this would be 7 by 40. So that comes out to be approximately 17.5%. Now the last part for movie recommendation or the market basket optimization is, we call this as a lift. So lift is something like, let's say if a particular person is watching Interstellar, so what is his likelihood to watch the Batman? So this is actually we calculate with the help of the parameter which is called as confidence divided by the support. So if we find like if we find this particular value for this part, so we have confidence is 17.5 and my support is 10%. So if you calculate the lift, so it comes out to be 17.5%. So the lift you can understand in this way, as like we have calculated the lift using this parameter, like 17.5 was my confidence and 10% was my support. So I got 1.75. So let's say this was one user who was watching Interstellar. Now, what will be his likelihood to watch Batman? Would be 1.75 times as compared to any movies. That is the intuitiveness behind this algorithm. Now, guys, we are going to see this algorithm into action, but let us see some steps which are involved. So, we are going to set minimum support and the confidence. Like, we will be finding the support in the confidence, and we will be taking the subset in transaction having the higher support than the minimum support. So, we will be finding the transaction in which we will be sorting the higher support than as compared to the minimum support, and we will be taking all the rules of the subset, like how many potential rules. So just like you can say, like with this association we got three potential rules. So our Python IDE will find the potential rules, and after this, like we will be sorting this in the descending order of the decreasing list. So let's see this thing into action in Python.